What's going on? It's Justin Dickmeyer from engineerintrainingexam.com, and in this video we will review power series. Now, a power series is any series that can be written in the general form sum of n to infinity c sub n x minus a raised to the n, where c sub n and a are both numbers. Now, the first thing to notice about a power series is that it is actually a function of x. Now, this is different from arithmetic and geometric series, where we've only allowed numbers in the series. Now we are allowing variables to be in the series as well. Now, a power series is said to converge at a point x if the limit as n goes to infinity of that power series exists for that specific x. Now, a power series certainly converges for x equals a, but the convergence for the remainder values must be determined. Now, the most useful test for convergence of a power series is known as the ratio test. So we use the ratio test to determine the convergence of a specified power series. Now, the ratio test tells us if c sub n does not equal 0, and for a fixed value, the limit as n goes to infinity of c sub n plus 1 times x minus a n plus 1 divided by c sub n x minus a raised to the n. Now, if that limit exists and is equal to the absolute value of x minus a multiplied by the limit of L, if that is true, if this statement is true, then the ratio test tells us that that specific power series converges at values x minus a times L less than 1, and it diverges at x minus a times L greater than 1. Now, if x minus a times L is equal to 1, now the test is inconclusive. So this is called the ratio test and is what we would use to determine the convergence of a specified power series. So let's look at an example here. Let's find the values of x where the power series converges for this power series. Sum n0 to infinity of negative 1 n plus 1 n x minus 2. Now, this looks like a complicated power series, but let's use the ratio test to tell us where, in fact, this power series converges. So we're going to use the ratio test. And the ratio test, once again, is the limit as n goes to infinity. And so we want to just add the n plus 1. We want to add 1 to the n values. So on the top, on the numerator. So the limit as n goes to infinity of minus 1 n plus 2 times n plus 1 times x minus 2 times n plus 1 divided by just the original power series, which is negative 1 raised to the n plus 1 times n times x minus 2 raised to the n. Now we can pull out the value of x minus 2 because we're looking for the limit of the n, the n's within this power series. So x minus 2 is simply just a constant in this situation. So we got x minus 2, and simplifying this ratio, we got the limit as n goes to infinity of 1 plus 1 divided by n. So we know that as n goes to infinity, this term disappears, and we got the limit's going to be equal to 1. So the ratio test is equal to x minus 2 times 1. So this tells us, the ratio test tells us that this specific power series, now it converges at x minus 2 times 1 is less than 1, all those values, and it diverges at x minus 2 times 1 is greater than 1. Now since we're interested in the values of convergence of this power series, that's what was asked from us. We need to determine what x values actually correspond to this term right here. We got x is equal to 1 and x is equal to 3. See, because if you plug that into this this equation, then it's going to satisfy it. This inequality is going to satisfy it. So we know that this power function converges on the interval 1, x, and 3. So let's look at another example here. Let's recall that just remember that the ratio test tells us that when the absolute value of x minus a times that limit is less than 1, then the series converges. When x minus a is greater than 1, that series diverges. Now notice on the right side here of this inequality that the value is equal to 1. Now if this value is not equal to 1, or it could be equal to 1, but if there's a value of L, some value over here on the left side of L, when you multiply that through to the other side and this 1 becomes a different number, say 2, 3, 1/2, whatever that is called, that term is known as the radius of convergence. Now, every power series has a radius of convergence. So what I want to do is go through a problem and just show you how that radius of convergence is defined. So let's find the radius of convergence of the power series n equals 0 to infinity of x plus 1 raised to the n divided by n2 raised to the n. Now, so first thing we want to do is just put into effect the ratio test, and that's the limit as n goes to infinity, adding 1 to the n value in terms. We got x plus 1 n plus 1 divided by n plus 1 times 2 n plus 1, and that's divided by, or we can just flip it and do the inverse of n 2 sub n times x plus 1 times n. Now once again we can take out the x terms because those are pretty much constants in this case. So we got the absolute value of x plus 1 divided by 2 after simplifying, and the limit as n goes to infinity of n divided by n plus 1. So we can see as n goes to infinity that this term is going to go away, and that our limit is actually x plus 1 divided by 2. So once again, the ratio test tells us that when the absolute value of x plus 1 divided by 2 times 1 in this case, L is equal to 1, is greater or is less than 1, then this series converges. And when the value of x plus 1 divided by 2 is greater than 1, then this series diverges. So notice how we have a value over here that's not really in the we have another value of division of 2 here. We want to get x plus 1 by itself. So what we need to do is multiply this inequality by 2. And that gives us x plus 1 is less than 2, and x plus 1 is greater than 2. So these values right here are the radius of convergence. So the radius of convergence R is equal to 2 in this case. So that's all I got for you guys today. I just wanted to do a quick recap on the power series and how you would find the convergence of a power series, and also just define a couple common terms. If you guys have any questions, head on over to engineeringtrainingexam.com. Shoot me an email, some feedback, suggestions, or whatnot. If you guys have any requests or whatever you have, just get a hold of me, and we'll be talking soon. All right, take care.